Okay, so let's look here. So guys, when you plugged these in right here, they did different things. Now, do you see that this guy right here is hanging out with the x? It's in the denominator with your x, right? This is in the denominator with the x. Okay, which way did these move? Left or right? So they moved left or right? Say it again. Good. It is a horizontal translation. Translation. It did transition from one point to the other. Okay, so with that, so it moved left or right or translated horizontally. Miss Evans, can you write a quadratic up there that's moved left or right? It doesn't matter. Okay, so look at what Miss Evans wrote up on that board. So y equals the quantity x plus 3 squared. Okay? What kind of translation was that? Everybody look to the left, the board on the left.
Remember the parent or quadratic is this. The parent.
Good, it moved left 3, didn't it? And what did we say? How do you have to, why does it, because it doesn't look like it moves left. What have we always said? The x lies to you, you go the opposite. So did you find out that to be the case here? When you put in y equals 1 over x, that's that one, right? And then if we're thinking that same rule existed, she said x plus 3, we said it moves left. This next one, it said to put in y equals 1 over x minus 2. So which way should that move it? Okay, that moved it to the left up there. Look, plus 3 to the right, didn't it? So if I put in 2 there, you should expect this thing to move. Did it move it to the right? So look, there you are. There's the new one. Did it move it to the right? Yeah, it just slid it to the right, didn't it? So here, it works exactly the same. The same rules apply. The exact same rules apply. Sam, are you graphing? Okay, so you getting it? Okay. We had somebody in 4th period playing some game or something the other day. So they're not going to get the computers back. So with that, we're just going to talk through it. With that, then it moved it. You can see if you unhighlight it, remember it takes it off the graph, and then it moves it. Okay? So with that, where was this asymptote, the vertical asymptote of this guy? Remember, it moves up and down. Where's this vertical asymptote? X equals 0. If it moves to the if it moves to the right 2, where's the vertical asymptote going to be? 2, right? So you had your x equals 0, and you're going to move it to the right 2. So your vertical asymptote is going to be x equals 2. Okay? So did that graph move up or down any? No, it didn't. So where was your horizontal asymptote?
0.
Yep, so it's still at y equals 0. Okay, so it didn't move anywhere. So the parent graph, and this graph have the same horizontal asymptote. Now, we said, and that's why I said get your notes out to look. We said that your domain then basically was all reals, but x could not equal 0, right? So what is this domain going to be? all reals, but x cannot equal 2. Look. It can't equal where the horizontal asymptote is. What happens if we plug 2 in here? Good. You would end up with 1 over 0. We talked about that on Friday. We talked about that being the 1 over 0 gave you the error. Okay. So here, does this range change at all? Nope. All reals, but y does not equal 0. Look, it still used the horizontal asymptote. It still used that horizontal asymptote there, okay? Now, what happened when you plugged in this guy to your, and what do you mean the other way? Yeah, it went left too, didn't it? Okay, so it went left too, so where's then the vertical asymptote going to be? Good, -2. You guys, it's always, you're thinking about where did it start, and the parent graph has the asymptotes at x equals 0 and y equals 0. So if we move that, then this is going to be x equals -2. Did it move up or down any? Nope, so this is still correct. The same, y equals 0 is the horizontal asymptote. And then, so what is the domain of this guy? Good, x cannot equal -2. And look, there you go. You tell me what the asymptote is, then you tell me it can't be included in your domain. And the same thing here. All reals, but y cannot equal 0. Okay, so look, shifting the graph horizontally changes the vertical asymptote and the domain. So that's all we did there, was change those two parts. So now let's look up at what happened here. So is this guy hanging out with the x? No. So Miss Evans, would you give me a plus or a minus something up there? So everybody look over to Miss Evans and look at this function she's going to write. So what happened to that quadratic over there? Down 4. It moved down 4. So what happens with this guy? And then this guy? Okay, so this is going to move up or down. So it moves the graph vertically. It moves the graph vertically. Okay. So the vertical asymptote here, did we move it left or right at all with this guy? Nope, so the vertical asymptote is the same, x equals 0. The horizontal asymptote now is what? Good. It moved it the same way, so y equals -3. So let's look at that quickly. So here, so we're hoping it moves it, yep, moved it down, didn't it? So if I take that off, there it is, flash it, it moved it down. And it moved it down by -3. So instead of this horizontal asymptote being right here, the horizontal asymptote lies right here. And how did we move it? Down -3. So that horizontal asymptote is that we said. So when we look back then, and let's look at the range since we're talking about that here, it's going to be all reals, but What can y not equal now? Where did it move it? Good. So y cannot be -3. So this still, once again, is right there. And I didn't move it anywhere here, so this is exactly the same as the parent graph. And then what happened in number 3 right here? It moved it up. So where's your vertical asymptote? If it moved it up 3, where's your vertical asymptote? Listen to what I'm saying. It moved it up 3. Where's your vertical asymptote? Did it move it right or left? Did it move it right or left? No. So the vertical asymptote's the same. So this guy, so the vertical asymptote still is at x equals 0 because I didn't move it left or right. Now what you were answering is where's the horizontal asymptote? Really? Yes, this one moves it in the direction that it says. So then my range is what? Good. All reals, but y can't equal 3. And then this is all reals, but x can't equal what? Good. Okay. So shifting it vertically changes the horizontal asymptotes and the range. It doesn't change the vertical asymptotes and the domain. So be real careful when you're thinking through that. Okay, so now here we go. Here we go to the part that I said mathematicians usually do things very well. This is where we fell short, and we didn't because we are not smart enough to do any of this. The mathematicians that are dead and gone, with the letters, we're going to have to be smart about that, okay? So we knew right here that this is the graphing form of your quadratic. Or the vertex form, right? It shows you your vertex, and it would tell you how things are transformed, okay? Now look at this guy right here. So now this guy says my graphing form is y equals a over x. Well, now look at what x is hanging with here. So we're consistent. We add the vertical shift to the end, so that's your plus k. Do you see these guys right here use the same letters? So when we talk about transforming them, we're transforming them left and right, the opposite of k, up and down, sorry, left and right, the opposite of h is what I tried to say. The opposite of h moves it, because it lies to you, right? Correct? The k value moves it up and down. And so now this k, when we're talking about transforming them, you have to talk about the k as the vertical translation. And then, so we couldn't use the k here for the constant of variation, could we? Because they mean two different things. So this is where I was telling you that mathematicians drop the ball, okay? So now we go back to using the A being that vertical stretch or compression. So let's fill in some notes here. We just said that the value of A represents a vertical stretch or compression. Okay. What happens if the A value is negative? What happened if that thing was negative? What did it do? You just saw it on Friday. It reflected it, right? Over where? Yes, we've only reflected over the X here. So that represents a reflection over the x-axis. a reflection over the x-axis. That's the same rule you learned as soon as you learned to transform something.
Instead of it being like this, it would be like this. Because this
Okay, so hang on, give me a second. Let me get it backwards. So this is where we start for you, and then it would go here. Yeah, okay. So the value of h does what? The value of h translates the graph which way? Oh, did you say it? Left to right. You said it so fast I didn't process that. For some reason I thought you said something about direct, like left or right. I got you. It also gives us the vertical asymptote. So here, x equals h. Because remember, if x equals h, then that gives you the 0 on the bottom. So that tells you where that line is. You've done it, we're just putting it in letters and it looks a little harder. What about the k? What does the k do? Shifts it, yep, up or down? And the horizontal asymptote is going to be where?
X equals, or Y equals H.
Good. Y equals K. Up and down. Now, look here. The corner points will be plotted from the intersection of your asymptotes. So the way we're going to move this guy is by moving the asymptotes. Okay? So let's look here to graph them. Last page. We're going to get through this pretty quickly here. To graph them, you want to find the asymptotes first. So you want to find the asymptotes and graph. Okay? Step 2, so you're going to find the asymptotes, you're going to graph them. Step 2 is you are going to find corner points and plot them from the intersection of the asymptotes. Okay, so you're going to find the corner points and you're going to plot them from the intersection of the asymptotes. Asymptotes, yeah. And then step 3, you're going to draw what kind of curve? A smooth curve, right? Approaching what?
0,
Friday, it was approaching x equal. Yeah, we're going to draw a smooth curve approaching the asymptotes. Miss Evans, can you grab computers, please?
Guys, go ahead and,
Yes, or just log out.
Shut it down or whatever.
Log out.
shut down.
That's fine. Okay, so now you have all you need to know. But you also notice that we put describe the transformation there as well, didn't we? We said describe the transformation. So first of all, I said find the asymptotes. So if we look at this, I'm going to kind of do this in a little different order. So, or I guess you can tell me the transformations. What does this do? What is the left 2 and good. Moves left 2.
So there's no vertical structure.
Not for this because we don't have, that's just 1, right? Moves left 2, down 4. Okay? So now with that, I guess we can go in order. What is my A value here? 1. So the square root of A is 1. Okay. The vertical asymptote you said to be what?
4.
2.
Vertical asymptote right here, ladies and gentlemen. It's x equals
Positive.
Negative.
Negative. Okay.
x lies to you, your ex-girlfriend, your ex-friend, your ex-best friend, your ex-whatever. Liar, liar, pants on fire. So you move it to the left 2. So your vertical asymptote, instead of being at x equals 0, is x equals negative 2. What about your horizontal asymptote? Y equals negative 4. Okay, so you found all that good stuff.
What are the corner points? How do you find the corner?
Hang on, we're going to talk about that, okay? Do you notice I didn't even put a blank here for corner points, right?
Yeah.
And I'm going to show you why right now, okay? We're going to still use the idea. So did you graph your asymptotes? It should have been at negative 2. So theirs equals negative 2. That's one asymptote. And then your other one is down at negative, y equals negative 4. Okay. So now, look here. Step 2 of this said to graph your corner points from the intersection of the asymptotes. Where did our asymptotes intersect on our parent graph? No, the parent graph was just the x and y axis, so it intersected at 0, 0, the origin, right? The parent graph intersected at 0, 0. But now we've moved over left 2 and down 4. So we've taken this axis, the asymptotes, and we've gone left 2, down 4, okay? So from this intersection, you're now going to plot these points. So in this case, right here, so I'm going to go, we said we go by the K value. Well, now we've changed that to A, right? So we are going to find the corner points using 1. Good. So from this, you go over 1 and up 1, or rise and run, whatever you want to do. You go up and over. And there's that point. You also go in the other direction to the left 1 and down 1. You use that A value to do that from the intersection of your asymptotes. Now, the reason I didn't ask you to give me the ordered pairs is you then have to go back and count from the origin. And it's just a little confusing, and in the great scheme of it, it's not that important. Once it's been shifted, it's a little harder to see where the corner points are. I mean, you can, because this corner point would have been at negative 1, negative 3, and this one would have been at negative 3, negative 5, it looks like. But now you draw a smooth curve approaching the asymptotes.
And Caleb, you had asked, do we need to draw those asymptotes? I said, you'll see why. It's really important.
Yes, you have to draw the asymptotes. If not, you don't know how to draw your graph. And hopefully yours will be a little straighter than mine was there. Okay? Mine went wonk. These 2 points? Okay, are you talking about this is the bottom point? Okay, why doesn't it connect with what? This one? The nature of them, remember, one goes in this quadrant and one comes down in this quadrant. They never cross. It's just, it is the graph, and it's not defined at that one point. And this point is x equals negative 2. It's not defined there. So that graph's going to kind of come here and graph. It freaks out, then it jumps back, and it finishes out like that. Okay, Anthony?
Those lines, like the 2 lines vertical, they don't have to be vertical, right?
You mean your asymptotes? The smooth curve?
Yeah, like, as long as you get the point right, it doesn't matter how far it goes, like how far the lines go.
You need to show me that it's approaching. You can't do me just a little graph like this. You have got, if you did this, you need to give me more than that. You need to show me that. But yeah, if you stopped it right here, it would have been fine. But it's got, or if you stopped it way out here, that would have been fine as well. But it can't, you've got to make sure I can really see what it looks like. Okay, so now let's look here. The domain.
All real numbers except that x does not equal -2.
Good. Use your vertical asymptote. That's where it tells you it can't be equal. So all real numbers, but x cannot be equal to -2. Range. All real numbers. Yusuf.
But y can be equal to -4.
Good. Y cannot be equal to -4. Okay. Your increasing and your decreasing is working exactly the same way here. So when I'm coming this way, is this graph increasing or decreasing? Decreasing, even if it freaks out and jumps up. So there is no increasing interval. You can write none or you can write no increasing interval. Okay? It's decreasing. All reals but what? Right, it's where the x can't equal, right? So all reals, but x cannot equal -2. Wow, it looks just like your domain, doesn't it? And what about the end behavior? Now this is what we talked about on Friday. We said, as x approaches positive infinity, what does y do?
It approaches the -4.
It approaches -4. It's approaching that horizontal asymptote. So look, this right here is from that value right there. It tells you where it can't be, so that shows you it will never be equal to that, but it is approaching.
And then the next line would be the same thing, or not same thing,
As x approaches negative infinity, what does y approach?
-2.
So you're going to say this is going to be up here at -2 again? Guys, look at what's happening. As this goes this way, do you see it's approaching that line? Well, if you're going to negative infinity, what does this approach here? That same line. It always approaches that same horizontal asymptote. So both of these guys, in this case, will be the same, and it's from that right there. Okay. So now let's get through this next one because it's flipped, and if we get through here, we're good. Okay, so we said, which quadrants did these guys kind of lie in? It shifted a little bit, but if it hadn't been shifted, they would have been at 1 and 3, correct? Okay, this is where you're going to have to smack yourself in the head a couple times and make yourself some notes, because there's a good chance you're going to end up plotting it in the wrong place. So make sure you show me all your other work so I can give you most of the credit in case you mess this up. But this is a use your noggin, okay? So here, what is happening here? What does that negative do in terms of a translation?
Makes it a 1, 2 instead of a 2, 4.
Said,
Out
What?
1, 3 instead of a 2, 4.
right, it does it in, no. Is it?
It goes in one quadrant, one.
It reflects it over the x-axis, so it's going to move it, Jack, technically into the 2 and 4. Okay, so this is a reflection over the x-axis. So that's your reflection over the x-axis. What does that 25 do? Good, it's a vertical stretch by a factor of 25. So it's a vertical stretch by a factor of 25. Okay. And what does that negative 2 do right there? Moves down to, good. Okay. What is your A value here? 20. No, don't ever use the negative, because what's the negative do? Reflects it. That's the only thing you use that for, is the reflection. And what I might do is maybe say, wow, remember reflection. Reflection. Hopefully that'll help me remember to plot it in the right place. So if A is 25, what's going to happen if you take the square root of negative 25? It's going to give you an error.
Yeah, you can square it.
It's an imaginary number, so you know how to do that, but you can't graph it on a real number line or number coordinate plane. So A is 5, right? Okay. So where's your vertical asymptote? Has anything with x? Nope. So tell me x equals 0. Horizontal asymptote? Good. Y equals negative 2. Okay. So graph those. So here you have x equals 0. And you have y equals negative 2. Okay? So I have my reflection that I wrote right there. I also know that it's going to move from this new origin. This is my temporary origin, right? It's going to move 5. So you can, we just looked at going over 1, up 1, over 1, down 1. Good. You also can look at that moving the diagonal distance of 5. So you can look at it either way. You can start here and you can go 1, 2, 3, 4, 5 and give me that. Or you could have gone left 5, up 5. Now you had to remember it was reflected, so it goes in that quadrant. And then here you go 1, 2, 3, 4, 5. And there's that one. Now you're going to draw your smooth curve. So it's going to be approaching like this and approaching like that and approaching like that and approach. You don't want to get a what? A bird. Don't get a bird.
So why is number 2 like that one's an actual curve, but number 1's a straight line?
Number 1 is not a straight line. It's just closer, so I had to curve it a little faster. It still curves around. Because it was closer to the new origin or the intersections of the asymptote. So just by the nature of it, it made it move like that. That's a good observation. Nice job. So now what about your domain? Are real, but x cannot, that's trying to be an x, cannot equal 0. Range all reals, but y cannot equal negative 2. Use your asymptotes. So now this guy's increasing the whole way, so there's no decreasing intervals, so there's no decreasing, and it's increasing where? All reals, but x cannot equal 0. So your interval, whether it's increasing or decreasing, is going to be exactly the same thing as your domain. And the end behavior. As x approaches positive infinity, y approaches, what is my horizontal asymptote? Good. Y approaches negative 2. Okay, so if you move left to right, okay, you're only moving left to right. As soon as you see that curve, if you were running on that curve, are you going to be running up a hill or down a hill? Just right here, Anthony, are you running up or down?
Oh, that one's up here.
Okay, so then what happens at the point of where it is not defined, it freaks out, and it would throw you way down here. We're still moving left to right, so are you going to be running up a hill or down a hill? Up. So it's either increasing if it's reflected, or it's decreasing if it's not. And you always have to remember moving left to right. You can't look at it right to left, because then it flips it.
So it doesn't go based on where the graph is, like on the,
Well, even if I started right here and I was moving left to right, am I moving up or down?
well, that's not what I'm saying. I mean, yeah, there was a lot, like, I'm trying to, so like, number one, if the graph on the left, that was a little bit taller, so it was up in the positive half. Yeah.
It has to be reflected to do that. It doesn't matter if it's moved up here, it still has this nature.
So it still equals.
Mm-hmm. Okay. Okay, so go ahead and work on that number 3 real quick, and I'm going to give you your homework. You can do this without a calculator. You do not need a calculator to do this homework.
Oh,
So guys, we will be in here at Smart Lunch if you want to come get some help. We can quickly look at where these asymptotes are, though. Where's my asymptote here? My vertical asymptote. Good, x equals 1. And you need to tell me the equation of it, okay? Be careful with that. And what about your horizontal one? Good. If you do that, then you've done a lot of the hard work. What is my k value, or my a value? 9, square root of a, 3. Is it reflected at all? No, so it's going to be here and here. So go your corner points from this point of intersection. And then you've got your smooth curve.
Yeah, but I mean, the two don't need to be here. Yeah.